Hello guys, so today we'll be solving Leetcode question, maximum performance of a team. So you're given two integer n and k. N is equal to the number of engineers, k is equal to the maximum team numbers, right? So you also given a 2D arrays, speed and efficiency, which represent the speed and also the efficiency of each engineers. So we have to choose at most k different engineers out of the n engineers to form a team with the maximum performance. So the performance is calculated by taking the sum of the engineer speed multiplied by the minimum efficiency among each engineers. So you can take a look at the example. If we take if we take this guy like 4 and we take this guy, then we will have a score of min 4 5 multiplied by the sum of the engineer speed, right? Which is like this, right? So we will have 4 7. Oh, sorry. Choose this guy, right? So it's like we choose this and this guy, right? So we have performance score of min 4 7 is equal to 4 multiplied by 50, which is equal to 16. Okay, so like the formula is formed by two different parts, right? The mean of the efficiency multiplied by the sum of speed. So we can treat each of these elements as the mean point, right? We can treat each of these guys like a pivot point and then find out if we treat them as a minimum point, then what is the maximum score that we can get, right? So it could be much easier if we can sort the array like this. As you can see here, I'm sorting the efficiency from high to low, and then I'm sorting the speed after it, right? So if we treat this guy as the minimum efficiency guys in the team, right? And because here's the largest, the guy with the largest efficiency out of all the engineers, then we can choose any guy with a larger efficiency, right? So if we choose this guy, then he should be on its own, and then the performance of the team could be 9 multiplied by 1, right? And then it could be 9. So what if we choose this guy? Now we see there's one guy that has a higher efficiency than him, and then probably we will form with this guy to form a team, right? These two guys will form a team. Then the performance score of the team could be 7 multiplied by 5 plus 1, which is equal to 42. And for this guy, okay, so we choose this guy. We have two candidates that we can choose from, which is 7 and 9. the guy with the 7-point efficiency and 9 efficiency. So which one of them could be better, right? So this guy has a higher speed, so probably we will go with him, right? So we take 2 plus 5, which is equal to 35, right? Okay, coming to this guy, we have 3 potential candidates that we can use to form a team, right? And out of all these, this guy has the highest speed, so we form it with him and we get the best result. Okay, hopefully. Okay, okay, so what's the approach here? The approach here is that we're going to sort the efficiency from high to low, and then we sort the speed after it, right? To maintain the order, the original order of the array, right? After that, then we need to find a way. If we doing it in brute force, for each of these guys, and we compare it to all the previous guy, find the max, sum them up, multiply, sum them up, it could be O(n) squared, right? And it could not be really efficient. We need to find a data structure that allowed continuously updating and popping out the minimum element, right? So what do I mean by that? So if we come into this guy and we have we know that we need to keep our candidate at most 2 engineers in the best candidate, right, pool. Let's call this pool. So if we come into this guy and we are having 1, 5 in our list, right? 5, 1. And we have this guy, and we need to insert it into the pool. After we insert this guy into the pool, then we need to pop the guy with the minimum value out to maintain the size of the pool, right? It cannot be larger than k. So what data structure allowed us to continuously update the sorted, to maintain the order of the array, and then continuously popping out the minimum element, right? Is a min heap. We will be doing a min heap here. So for each of these elements, for the first guy, the heap is empty, so we will just take 9 multiply by 1. So we add 1 to our min heap, and then we come into 7. We know that there's 1 in the pool, so we get 5 plus 1. We add 5 to the heap. Okay, coming to this guy, we will, we have, I'm sorry. Okay, so coming to this guy, we only allowed to keep at most k minus 1 engineer in the pool. We need to take into account the current engineer too. So coming to this guy, then we could pop this guy out. Okay, so it could be okay, 5, 2 plus 5, right? So we push 2 into this and we pop this guy out, so the pool remain. it's still 5, right? After that, we're coming to this guy. We know there's a 5 in the pool, so we get 4 plus 5. We add 10 into the pool. We pop the mean guy out, and then we're coming to this guy. We know there's a 10 in the pool. We put 3 in, we pop 3 out. We repeat the process, and then we keep on updating the result. Right? So that is our approach. So let's implement it. Okay, so since the answer can be a huge number, we need to return it module, whatever this is, right? So need to import the heap kill module, and then candidate we need to sort these guys, right? We need to sort this guy from high to low, and then we need to sort this guy after it, and so we can do it by using zip. Okay, so zip it is equal to sort zip speed f zip speed efficiency reverse true. It's been a long time since I used it, so let's get kind of this. We need to sort by efficiency and speed. After that, we can do sort. We can do like speed is equal to I1 for I in zip, and efficiency is equal to I0 for I in zip, right? See if it, let's see if it write correctly. Okay, here. Okay, yeah, I think we do it correctly. Okay, so here's the min heap, right? Here's where we storing all the candidate. So we will do a for loop. We have to initiate a resolve variable called res. This initially we also will be initiate variable called total speed to keep track of the total sum of the speed inside the pool, right? Because we can not be recalculating the sum of these guys for every pass. It will be O of n squared, right? Like if k is equal to length of k is equal to n, it could be O n squared. It could not be really efficient. Like 0. So for I in range n, right? So the best could be q total speed, if q, if there's something inside the q, right, let's call it q, else than just 0, and then we'll update the rest is equal to max the whatever the speed I, right, multiply by efficiency I plus best total speed, right? Okay. After that, then we will update the, we need to push the speed I into the queue, right? Need to put the speed I into the queue, and then first we need to total speed plus equal to speed I, right? And then if length of queue is larger than k minus 1, right? Because we can only keep at most k minus 1 candidate in the pool. If we keep 2 guys in the pool and then we also take the current guy, then we will have a team of 3, and that will violate the constraint of the problem, right? So we need to keep at most k minus 1 guy in the pool. So if length q is larger than k minus 1, we will need to pop the minimum guy out. We'll do hip q, hip pop q, and then we will decrease the total speed equal to the amount of the guy that's just being popped, right? Okay. We need to push, after updating the total speed, we need to push the speed of the current guy in queue, right? So we do hit queue, hit push, queue speed I. After that, then we just return rest. And we need to module the answer by this guy, right? What the hell? What did I do wrong? Okay, so let's debug it with me, guys. Q. What the hell? Oh, fuck. This like should be equal to efficiency I plus speed I plus total speed, right? Yep, okay. Let's submit it. Okay, so the previous time I submitted is a lot faster. Okay, so the time complexity of this O n log n space complexity O n worst case, right? So okay, so when you for loop, that's n. Okay, so in each loop then we will need to keep pushing and popping out of the heap side k, right? And that's log k, right? But in the worst case possible, then k will be equal to n, and that could we need to take into account of the worst case. So that's O n or log n, and also the space complexity is OK, where k is the maximum number of engineers in the team, right? But in the worst case, then k will be equal to n. So here's the time complexity and space complexity. I hope it makes sense to you guys, and see you guys later. Thank you for watching.